Day 264 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 53, maximum subarray. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's get started, y'all. Question says, it's a pretty simple question today. It says, given an integer array nums, find the subarray with the largest sum and return its sum. So it's pretty simple, self-explanatory, but let's look at example 1 just to make sure we know what exactly it is that they want us to do. And the first thing we need to do is we need to understand what a subarray is. So let's look at the definition. It says a subarray is a contiguous non-empty sequence of elements within an array. So what that means is we need the contiguous, meaning the numbers are lined up next to each other. We're not just picking a number here and then we pick a number here, then we pick a number here and try to find the largest sum. No, we want a subarray of contiguous non-empty sequence, right? So all of the numbers in the subarray have to be next to each other like this, or they have to all be in basically an array inside of the array, right? We would have to be able to create one array inside the initial array, right? Something like this. If we had it like this, we had a 1 and a 2 and a 4, that's not an array inside of this array, right? But see, this could be a subarray, this could be a subarray, all because the numbers are lined up next to each other. So let's go through this input and output so I could break it down a little bit further. So in the input, we have nums equals an array of integers -2, 1, -3, 4, -1, 2, 1, -5, and 4. The output is 6. Explanation says the subarray 4, -1, 2, and 1 has the largest sum, which is 6. So we're actually returning the sum. We're not returning the subarray itself. But as you can see, all of these numbers right here, they all line up next to each other, which is what makes it contiguous and makes it a subarray, right? So 4 plus -1 will give us 3, plus 2 will give us 5, plus 1 will give us 6, right? Where say we did it like this, right? This is also a subarray. It just doesn't have the greatest sum. So this would be -2 plus 1 would be 1, plus -3, that give us back to -2, then plus 4 would be at 2. So the sum of this would be 2. We want the maximum. Same with this. This would be a subarray as well. It's plenty of subarrays in here, but we want the one with the maximum sum. And in this case, this is the subarray with the maximum sum. So just remember, a subarray, the numbers have to be lined up next to each other. We're not just picking and choosing the highest numbers in this input array. We have to pick and choose the numbers that is going to give us the largest sum in a subarray that are lined up next to each other, right? So let's look at example 2 so we could break it down a little bit further in case they try to just give us one integer, right? So in example 2, we have the input nums equals 1. The output is 1 because the subarray 1 has the largest sum. There's only one integer, so there can only be one output, right? There's only one sum if there's only one integer. So now let's look at example 3 where the sum is a little harder, but it's the same, a little higher, but it's the same principles, except this time, well, let's get into it. It says input nums equals an array of integers 5, 4, -1, 7, and 8. The output is 23. The subarray 5, 4, -1, 7, and 8 has the largest sum. So in this case, they just added up all the numbers together and that gave them 23. But that still counts as a subarray because all of the numbers are contiguous. Where if all the numbers were not contiguous, then it wouldn't be a subarray. But since all of the numbers are still contiguous, it allows us to, it's also a subarray, which allows us to include it in our input. And so the output of this would be 23 because when you add all of these numbers together, it'll give you 23. So now that we understand what the question is asking, y'all, let's get into the fun part, the actual solution, y'all. And this solution is probably one of the easiest solutions we've done in a long time. So don't worry, we're going to get through it pretty quick and painlessly. So let's get started. Now, the first thing we need to do, we're going to initialize let me see. Let's come up here. We're going to initialize a variable. We're going to call it current sum. We're going to say var cur sum, and we're going to set that equal to nums square bracket 0 just to start. And this is when we initialize cur sum with the first element in the array. So that's what this is. This square bracket 0 represents the first element in the array. And this is going to represent the maximum sum of the subarray ending at the current position. Now we need to initialize another variable. We'll call it max sum with the first element of the array as well. And this is going to keep track of the maximum sum of the subarray that we've encountered so far. So in order to do that, we could just say var max sum equals nums square bracket 0. And once again, this is going to keep track of the maximum sum of any subarray that we have encountered so far. Now we need to iterate through the array starting from the second element. So in order to do that, excuse me y'all, because remember this is already the first element. So in order to start from the second element, we're going to say for I in 1 up to up dot dot less than sign nums dot count. Then we're going to open up the brackets. First thing we need to do, we need to update cur sum by taking the maximum of the current sum and nums of I, which I will be whichever one we're on so far, right? So in order to do that, we're just going to say cur sum equals max, open up the parentheses, nums square bracket I, come outside the square brackets, say comma, then we're going to say cur sum plus nums square bracket I. So what this is going to do is the sum of the current element and the previous subarray. So cur sum is going to represent the previous subarray, and then when we add the current element, which will be nums I, we're going to take the maximum, and this is going to ensure that we start a new array if we get a better one, or if we get a better sum. So this right here is going to represent the previous subarray, and this is going to represent the current element that we're working with, and whichever one is bigger, the current element or the previous subarray plus the current element, we're going to return whichever one is bigger by using this max. Now we need to update max sum to the maximum of its current value of cur sum, and this is going to ensure that max sum always holds the largest subarray seen so far. So in order to do that, remember we just updated cur sum. We just updated cur sum. Now we need to update max sum. So in order to do that, we're going to come right here and we're going to say max, should be max sum equals max, open up the parentheses, max sum, comma, cur sum. So once again, this is going to ensure that max sum always holds the largest value, or the largest subarray, whichever that may be, because this max right here is going to return whichever one is larger, max sum or cur sum. Boom. But we're not done yet, but we're pretty much done yet, because we already know max sum is going to hold the largest subarray that we found so far. So now we just have to return the largest subarray that we found so far. So who knows how we can do that? Pretty simple. You guessed it. All we have to do is say return max sum, just like that. And that's it. That's the code. That's all she wrote. Let's run it. See how it runs. Make sure it runs how it's supposed to. Drum roll. And it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. I told y'all this was one of the easier solutions that we've done in a long time, y'all. And look at that, y'all. 0 milliseconds beats 100% of users with Swift. Not too bad, not too bad at all. Those are some good numbers right there. Those are the numbers I like to see. Those are the numbers we all like to see. And you know what else I like to see? Excuse me, y'all. You know what else I like to see? I like to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.